Hello world and TOC fans. My name is Ricardo and I speak from Lisbon, Portugal. Let me start by a belief. I think that the most important word in TOC's 5 focusing steps is the word inertia. Why? Because the most difficult thing to change is perhaps the way we think, due to our inertia. I've been studying and working with TOC since 2009 on topics such as throughput accounting, thinking processes, and of course the topic that brings us here today, which is critical chain project management. So maybe a good starting point is the following. If we agree that the strategic and tactic tree of CCPM is full of wisdom, are its concepts being implemented correctly? Are we fully exploiting each of the sensible sentences within the tree? What I'd like to talk to you about today is the work package project management. We all know that in TOC, the role of these professionals is a little bit different from the conventional view. So let's start to remind ourselves the corresponding necessary assumption, which is there are cases in which task managers cannot take an effective action to minimize, eliminate delays. Now, as always, here comes a straightforward objective. Project managers are driving a project buffer recovery process for cross-departmental actions and exceptions not handled by task management. Simply put, we want to recover at least part of the project delays. Let me emphasize the importance of this objective based on a cause and effect relationship between metrics that I consider relevant. For example, it's obvious that project buffer recovery is important, but we have to do it in a timely manner, right? The shorter the recovery time is, the more we protect project's lead times. And with that, not only project buffer at completion is more protected, but so the percentage of projects that finish on or before the due date. On the other hand, it may be that by recovering project's lead time, we'll be impacting the company's virtual drum. This can happen if that recovery affects in a positive way the integration phase. In other words, we'll be speeding up the so-called mean time between projects, or the speed at which the company completes projects. And yes, by that we can impact both projects' throughput as well as the throughput of the company as a whole. So, as a first conclusion, do we have a consensus that project recovery buffer lead time plays a very important role here? If yes, how can we reduce it? So let's go back to what is written in the strategy and underline the word process. How many of you have a standardized process regarding a buffer recovery plan? Is it a triviality? Note also that the tactic of this strategy is somewhat vague in this regard, and it doesn't mention anything very specific about it. So, without standing on the shoulders of a giant, I will try to make my contribution to what can be seen as a good practice in this regard and as far as the role of project manager is concerned. So, let's do it. We have our project running, and yes, we plan thoroughly by using risk matrices, failure mode and effect analysis matrices. We tried as far as possible to quantify the risks that appear along the way, both qualitatively and quantitatively, but we all know that our dear Murphy doesn't give us a break. So when we start to see a growing trend in our fever chart, we try to stop the problem first at a more local level with the help of technicians. with the help of the task manager, but when we see that the actions become insufficient and it becomes evident that we're going to be in the yellow or we're already in the red, now is the time to develop the recovery plan and then to deploy it. And this is not at all easy to do, because we all know that activities have already been cut in one half during the planning phase. And if we want to see a positive trend in burn rate, we'll need not only to recover the time lost in the current activity, but also to find smart solutions so that future activities last no more than their original durations, to say the least. This is the only way to reduce the burn rate and recovering some of the delay. So we have here a very good reason to put the project manager and his team working together in the buffer recovery plan. Yes, this has to be understood as an effective risk management tool. But before we dive in an example, let me explain in less than 30 seconds what a fever chart is for those who are less familiar with CCPM concepts. The fever chart helps us to understand where we are. In a true lean fashion way, we always want to know if things are ahead or behind schedule. On the x-axis, the percentage of the critical chain completion is measured. When we reach 100%, the project is completed by definition. And on the y-axis, we measure in time the protection of the critical chain already consumed. Thus, if the project has barely started and the buffer is already quite consumed, we're behind schedule and therefore in the red. If the project is quite completed and the buffer consumption is low, we are quite ahead of schedule and therefore in the green. So let's see an example. Let's assume that the planned duration of the entire project, already buffered, is 150 days and we work only on weekdays. Here we have our original PERT CCPM in gray, and as of April 19th, we only have 3 critical activities completed as the green bars show. We are currently executing activity 4, a critical project activity, and it is known that by its end we'll have 25% of the critical chain completed. Nevertheless, there's a high chance we'll face a buffer consumption of 60% by that time. Clearly, there is a strong probability here that the project will be in the red with a burn rate of 2.4 because 60 divided by 25 is 2.4. What more can we extract from the fever chart? If the total duration of the project buffer is 50 days, it means that the estimated penetration will be 50 days times 60% or 30 days when activity 4 is completed, right? In this sense, the first question that the project manager and his team need to answer is: what is the velocity at which we have to recover project's buffer and in how many days? But what does buffer recovery really mean? For me, it's putting the burn rate back on the line that separates the yellow zone from the green zone. Does it make sense? If so, we now need to define which critical activity will be in that condition. Let's assume that the project manager says that the burn rate should be on this line when 50% of the critical chain is completed, and that, hypothetically speaking, corresponds in our planning when we finish activity number 6. But is it feasible? Is it viable? We'll see. Note that if the decision had been to cross the line with 74% of the critical chain completed, buffer consumption would have remained at the same level and the recovery plan would have been less aggressive. But in this case, we are demanding a reduction of 20 percentage points, which is equivalent to 10 days because a delta of 20% times 50 is 10. Next, we calculate the respective calendar dates when 50% of the critical chain is completed. That is, when activity 6 is finished, we'll have a penetration in the project buffer of 20 days of delay because 50 days times 40% equals 20. Now, according to the initial PERT CCPM plan, the completion date of activity 6 corresponds to day 50 of the project, and by adding 20 days more, we arrive at June 6th, a Tuesday. What has to happen that day? Activity 6 has to be finished. Starting tomorrow, we have 34 project days to not only finish activity 4, but also activity 5 and 6. Just a moment ago, we thought we would do this in 44 days. 19 days for activity 4, plus 10 days for activity 5, plus 15 for activity 6. And now we want to do everything in 34 days. Let's draw the recovery goal on the fever chart. Here it is. The team now knows which activities are included and will be affected by the buffer recovery plan. All that occur between activity 4 and 6, including feeding lags, if any. Well, but this is just an intention to reach June 6th with activity 6 completed, all in 34 project days. To understand if we are getting there, the team needs to answer the following questions, which I suggest to be in the following order. For example, is it possible that we are working on project's content that the customer really doesn't value, and when we give up that content, we would save time? Yes, there's a lot of inertia here, and it's not very easy putting people to recognize that they may be working on waste or on things that the customer values very little. But of course, it will be a huge help if the answer is yes. And I think that if we recall our experience, it's not that rare to happen. Let's move on to the next question. What definitions of done can be challenged and, if challenged, will lead to an acceleration of completion? Another question. Can we split a critical activity in two if we have the resources? Look, activity 6 can only be started after activity 5 is finished, right? Not really. What one should do is to look at the group of tasks in activity 6 and understand the tasks in activity 5 that really need to be finished so that activity 6 can be carried out. The tasks of activity 5 that do not impact the next activity must leave the critical chain, thus being executed in parallel, if there are resources for this. This will lead to a reduction in the critical chain. A bit identical to the previous question is there a flaw in the logic of the PERT which allows us to gain time? The answer is yes, there is. The thing is to find and understand if this flaw is big enough to redesign the PERT in some another way. Next question. Will adding more resources to the current and future critical activities help the project to have cumulative positive gains? Many times we don't populate the activities with the optimal resources, or we think we did, and now might be a good time to strengthen them up. Another question: is it possible to work shifts or work overtime to get cumulative positive gains? Of course, this may imply an increase in totally variable costs, but as Goldratt would say, life's a bitch and then we die, right? One last question. Can we resort to subcontracting? Will it help? Okay, so before we start deploying our aggressive plan, there's one more thing we need to do. We must go through the test of the predicted effect confirmation questions. One is: how can we be so sure that the respective actions will be effective? Again, here the inertia is usually high, or we don't even bother to think about it. We can say, I don't know, we'll see when we get there. But the more we invest in answering to this, the more assumptions will be mentioned and the higher the quality of the buffer recovery plan itself. Finally, how long does it take to see the predicted effect of these actions, meaning to see a reversal in the burn rate trend? All this information should be synthesized, summarized in a matrix similar to this one, so that in the meeting with top management, the project manager can communicate effectively and show the obstacles that may be ahead of this recovery. Note also that the date calculations are all parametric. We just need to enter the required input data. So we execute the plan, and then what? Then we still want to know the actual date the project returned to a yellow burn rate, the project buffer recovery lead time in days, but also the value of this lead time in relative terms of the size of the buffer. Finally, there will certainly be some lessons learned from this. But let me now talk a little bit more about managing this KPI, project recovery buffer lead time. Clearly, the direction of improvement is less is better. The accountable for it should be the portfolio manager and the person responsible, the project manager. When to update? Whenever recovery is finished, that is, from the time the decision was made to make the recovery plan, or if you will, from the time the activity with the biggest penetration in the project buffer is waiting for something, until we reach the recovery line, the line that separates the yellow from the green zone on the fever chart. My suggestion is to monitor this variable from a control chart, one data point per recovery plan on the horizontal axis. And of course, this implies knowing how to interpret the SPC, the assumptions for its use, and knowing when to react and not react. That is, whenever a point falls outside the control limits, it is necessary to develop an out-of-control action plan. But we're only just getting started, because there's so much more we can do with the fever chart. So I'd like to shift the focus to another box in the strategic and tactic tree, which is 4.15, mitigating client disruptions. Do you have this in your projects? Oh, I bet you have. So let us first recall the necessary assumption. Often the customer is the cause for the project to be late when certain inputs are communicated late and or requiring changes in specifications. And it's these changing requests that I'd like to talk about. So what's the point? The objective is the company has very high due date performance, even in cases where client inputs are required and or specification changes occur. In other words, someone starts by having a brilliant idea, either internally, or worse, the customer. And then we have to make a decision. Should we accept the change request? Yes or no, and why? In order to be helpful and to use the fever chart as a decision tool, project status must be up to date, and of course we're assuming that it is possible to translate the requested change into time. We need to understand in which leg of the project this change will have an impact and in how many days. Why? Because we want to estimate the increased consumption in the project buffer. For example, if the change doesn't affect the critical chain, then by itself it should cause no problems in terms of meeting deadlines. But if it does affect, then we need to understand the risk we are taking in not renegotiating the original due date. So my suggestion is the following. Whenever the result of the change leads to an estimated burn rate greater than 0.5, PERT CCPM may have to be readjusted, and consequently the original due date needs to be revised under a new contract. But if the burn rate is less than 0.5, project buffer should absorb the change with no problem. Here we have two scenarios, two changes with an equal estimated days of buffer consumption, but at two different moments in time. In scenario A, the project is 40% completed with a buffer consumption of about 10%. And if we proceed with the change, this will lead to a buffer consumption of 30, putting the burn rate above the threshold, 30 divided by 40. This puts the project very close to the yellow zone. But according to scenario B, buffer consumption will also be 30%, yes, but the project is already 80% complete. The corresponding burn rate is less than 0.5, 30 divided by 80. So in scenario A, my suggestion is to renegotiate a new due date in cases where the customer really insists on implementing it. This will require replanning. In contrast, in scenario B, there is a good chance of meeting the original due date even with the implementation of the change request. And for those cases where there are no changes in project's totally variable costs, the fever chart will be a good enough decision tool in local terms wise. But this is not enough. If there's one thing Goldratt warned us about, is that we need to do our homework and study all the ramifications that impact the global. An example will be to understand if the cash flow or the money in the bank will be affected. For this, we'll need to look for any changes in the dates and amounts of payments and receivables, as is shown on this chart. With that, we calculate the shift in our survival time, that is, how many weeks or month from now will we cross the zero mark for the first time. Of course, the smaller our cash buffer, the worse. Another example, in my view much more complex, is when by approving the change request we affect the company's virtual drum. For example, if it is normal for a typical project to stay in the virtual drum for a week, and now due to this change it has to stay for 3 more weeks, then this is something that will affect the completion rate of projects for the entire company. And there will be certainly a negative impact on customer satisfaction, even for those that are still in the pipeline. In fact, if the virtual drum is harmed, it will be very difficult for the change to go ahead, because the extra price that the originator will have to pay will have to compensate for all the dissatisfaction created in all other customers. something that, at least in my eyes, is not measurable. Let me emphasize this point. When you increase the duration of a project in the virtual drum, there is a domino effect, even when we plan a staggering buffer. Just like when you are queuing to buy bread. If the customer in front of you starts paying with 1 cent coins, everyone feels this delay. This is what happens when we delay projects in the virtual drum. I guess all of these examples only reinforce the idea that it is not enough to evaluate a decision in local terms, and because of that we have to be aware of inertia. We always need to establish the bridge between the local and the global. But I think that the TOC community is already very well aware of this. And that's all. Thank you very much for your time. And now I don't know if I'm ready to answer your questions, but at least I'm fully available.